Hello students, this is the Earth Science Reference Table Review tutorial for the Regents exam. So today I'll be talking about some equations on the first page of the reference table. So let's get started. So we already talked about properties of water and specific heats of common materials. So the first equation from here is eccentricity. And eccentricity is equal distance between two foci divided by length of major axis. So what is eccentricity? So eccentricity describes the path of a planet or a moon. Okay, so for example, the value of eccentricity is from 0 to 1. So that is, this is minimum and this is the max. It cannot go beyond 0 or 1. Alright, so if you want to find eccentricity, so this is describing the orbital path. So if you have, let's say we have the moon, and let's say this is our planet, the Earth, and this is the path of the moon, right? So eccentricity is telling you how circular the path is. If the value is close to 0, that means the path is circular. If it's 0, it's completely circular. If it is 1, that means it is very elongated, so something like this. The path is something like this. Okay, so it's like an extended circle. Okay, so to measure the eccentricity, what do you have to do? So you need to know the distance between the two foci. So let's say this is a planet. Let's say this is a star, the sun as a star, and this is Earth, and this is a focus point. This is the path of the planet. Okay, and this is f1 and this is, let's say, f2. So the distance between the two foci is here, right? So this is the distance between the two foci, and the major axis is actually from this end to this end. So this whole thing from here to here is the distance, sorry, this is the length of the major axis. Okay, so this is the length of the major axis, and this is the distance between the foci. So let's say if this distance is, let's say I'm giving you a value, this is 5 and this is 10, so the eccentricity will be equal to what? So this is 5, so 5, the distance between foci, divided by the length of major axis, which is 10. So my eccentricity value is what? 0.5. Okay, so this is how you calculate eccentricity. So let's look at some Regents questions. Okay, so I'm gonna show you two Regents questions. So let's look at the first one, which is simple. Okay, question number 154. So the diagram below represents the elliptical orbit of the Earth around the Sun. So this is the path of Earth, this is Sun, and this is another focus point. So the distance between the two foci is given, and you also have the length of major axis. So if you know the equation, the distance between two foci divided by the length of major axis, and if you look at these options, the answer is already given though. It's B, which is, you can see the distance between the two foci, and then you have the distance, not the distance, the length of major axis. So that's why the choice is B, which is very simple. Next one is a little different. So question number 161. So for this one, you have to be a little bit careful. So here, the problem is there is no value here. Okay, so how you calculate the value? So this is a graph, right? So from here you can actually assume that this is 1, going by 1. Okay, so if this is 1, this is 2, this is 3, and so on. So we are thinking that each space is 1. So if I like this, so this is 1, this is 1, this is 1, and so on. Okay, so we will start counting. So if you count carefully, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25. It's 24 or 25, I think. So let's say it's 25. So 25 is what? 25 is the distance between the foci, right? And now we need to know the length of major axis. So eccentricity is equal 25 and then divided by the major axis. So we already know this is 25. So all we have to do is find out the distance in here and over here. So we already know this is 25. So 26, 27, 28, 29, 30, 31. Okay, so if we do this calculation, 25 divided by 31, so you know this is 0.8. If we look at the choices, you can see the answer is 0.8. We can eliminate choice A at the beginning because we know that the value of eccentricity is from 0 to 1, so you can cancel A. So we now know that the value is 0.8. Okay, so that's how you do eccentricity. Alright, so the next equation, gradient. So what is gradient? The gradient is actually telling you the steepness of a slope. Okay, so how do you calculate this? So if we now go to the next part, so we don't need this for now. Okay, let's keep this anyway. So question number 6. So first of all, if you look at the equation, gradient is equal change in field value divided by the distance. So what is the field value and what is the distance here? So if you look at question number 6, base your answer to the following questions on the topographic map below. Shows the location of a stream. Points A and B are the locations on Earth's surface. So I think you already know about the topographic map and topographic profile, so it shouldn't be difficult. So the contour interval is 10. Each line, if you're starting from B, you can see this is 100, and this should be 110, this should be 120, and so on. Okay, so if you're starting from this, we can say this value is 90, and then you can say 100, 110, this value is 120. Okay, so if this is the case, first of all, the field value, what is the change in field values? So field values, they're here, A and B. So this is the field value, and you know the field value, the change in field value. So you started at 90 and you stopped at 120, so the difference is 30. Okay, so we know that the field value is 30. If you look at the equation, change in field value, which is 30 divided by the distance. Now to find the distance, we can actually, this is drawn to scale, so I'm going to use a metric card actually. So A to B, what is the distance? So from here to here, I can use a small mark. Okay, so this is the distance, and now if I match it here, I can see that this distance is approximately 3, right? So that's the distance between A and B, right? So that we found that this is 3, so 30 divided by 3, we are getting 10, and you can see the answer is 10 meters per kilometer. So that's the change. Okay, so that's how you calculate gradient. Let's look at another question. So this question is a little interesting. Question number 7. So you can see this in which description best compares the gradients of this hill. Okay, so how do you calculate this one? Again, we're going to use the same equation. You already know what is gradient. Change in field value divided by distance. So we have to compare different field values here. Okay, so which description compares the gradient? So here the first choice is saying AE and EB have the same gradient. So we can see AE and EB. First of all, they are not the same, because EB, if you use distance, you know that this is very different from AE. So A cannot be right. CE has a steeper gradient than ED. So CE, and now we are comparing CE and ED. So remember, A, D, C, and B are all same. The elevation of A, B, C, D are the same. Okay, you can see this is 220, so that means A, C, D, B, they have the same elevation, 220. It's the distance that is slightly different. So this is saying the C, option C is saying CE. So CE has a steeper gradient than ED. Is that so? So we can actually use this one again. So if you see that this one EC, we're gonna look at the distance, because you already know that the elevation, they're the same. So EC, look at this one. This looks pretty much the same though. So CE and ED cannot have a different gradient, they are the same actually. Okay, then D, CE and EE have the same gradient. So now we are comparing CE and AE. So again, we can use this. So that's EC or CE, same thing. Here, actually, sorry. So this is EC and this one. So I can see that AE is actually slightly, the distance between AE is slightly greater than the distance between EC. So D can be cancelled because they don't have the same distance. So now if we look at the choice B, we know that this is the right answer. But why this is the right answer? So B, AE has a steeper gradient than EB. So AE and then EB. So you can see EB, the distance is huge. Okay, and A is here. So now if we look at the equation, changing field value. So here the field value AE and EB. So for example, let's compare these two. So gradient of, let's say this is the gradient of AE, and we're going to compare it with the gradient of EB. Okay, so AE, we know that for both of them change in field value is the same, right? So if we are saying A, it is, this one is 220, this is 260, so that is 40. The change in field value is 40. This one is also 40. But here, this value, if we are comparing these two, they're different, very different. This value, let's say, we don't know because we don't have a scale. Let's say for A, this one is, let's say this is 4. This one is obviously, I would say this is like 3 times, at least 3 or 4 times of AE, right? So you can feed actually 4 EE in between E and B. So if it is 4 times, this value is 16 at least. So this gradient is 10, and this is, if you are saying this is 16, this value will be 2 point something. Okay, right? We can find the exact value if we want. So 40 divided by 16, this is 2.5. Okay, so AE has a higher, steeper gradient than, you can see this is 10. It's very high. This is only 2.5. So that's why the B is the correct answer. So this question is a little tricky, but you now know how to do this, right? Great. So now look at the third equation. That is rate of change. Change in value divided by time. So rate of change, let's look at a question. So I'm going to look at question number 2 from here. A glacier advanced down a mountain from an elevation of 2010 meter to 1780 meter in 5 years. What was the glacier's rate of change? Rate of change, the equation is change in value divided by time. So what is the change of value here? Alright, so if you look at here, so we started at 2020, 10, and then now it is 1780. So we just have to subtract 1780 from 2010 to actually see the change in value, because we need to find the change in value. Rate of change is equal to change in value divided by time. We already have the time, which is 5 years. We just need to know the change. So you can subtract, or we can use calculator quickly. So it started at 2010. Now this is at 1780. So that's 230. So now once we know the change in field value, we can use the distance. So 230 divided by the time, which is 5. So you know the equation again. Change in value divided by time. So you can again use a calculator, or you can do it here. So 230, this is 20, this is 30, so that is 646. So his value is 46. And make sure you use the units. Remember, this is meter and this is years, so the change is meters per year. Okay, I mean this one, 46 meters per year. Okay, so that is about rate of change. The last problem is about density. So we're going to look at question number 3 actually. So a cup of gold colored metal beads was measured to have a mass 425 grams. By water displacement, the volume of the beads was calculated to be 48 centimeter cube. Given the following densities, identify the metal. So density, the equation is mass divided by volume, the number 4 equation. So you need to know the mass and the volume. So what is the mass? Is given, which is 80. So we already know that our m is 80. Make sure you use the unit, which is gram. And then we oh, I'm sorry, I'm looking at actually question number 2. The mass is actually 425. So 425. And now we need to know the volume, which is given, which is 48. So mass divided by volume, 425 divided by 48, right? Let me just make sure I'm correct. Yep, 48. And this is in grams, and this is in centimeter cube. Make sure you use the units properly, so you can use the calculator again. So 425 divided by 48, which is giving us 8.85, so which is very close to copper, 8.86. So our answer is copper, so gram per milliliter. Okay, so that's all about these 4 equations from the reference table. So now you know all these 4 equations, and you know how to solve the Regents questions. Alright everyone, so I hope this video is helpful, and I'll see you next time with another video. Thanks for watching. Bye.